So now let's do some examples using this theorem, which I rewrote there. All right. I want to point out this. We're going to use Rogowski. So I want to point out one thing, because Rogowski does this and so does the AP exam. They'll have you calculate g prime of x, where g is the inverse of f, and then they'll give you some function, okay? If it's a multiple choice and they don't tell you that you have to use the theorem, just find the inverse of the function. This is one reason I don't like this theorem very much. Just find f inverse. It's not that hard. Plus 1 divided by 4 cube root. You just got a chain rule. It's easy. So, right, on 3 through 8, you would just find the inverse function and get the derivative of it. It's much easier than using this weird theorem. I mean, I don't know, much easier, but it's equally easier, so why learn a new theorem? Anyway, that's for problems like this, where you actually could find the inverse. It's easy to find this inverse. This is trickier to find, but you can do it. However, functions like 9 and 10, there's not really any practical way to find that inverse. So that's where you're sort of stuck with this theorem. But the thing is that you're also stuck with figuring out what g of 7 is when you don't even know what g is. So you're stuck with that. So that's the kind of trick that you end up with, is a function that we can't practically solve for the inverse of this function, but that means we also can't find the inverse of the function at 7. So that, you're just trading one problem for another. But anyway, we can still do this problem it applies to certain very sort of special cases where we can get the x very easily. If not very easily, we can at least see it. So number 9 says we have a function f of x equals x cubed plus 7x plus 4. And then we have the function g, which is f inverse. All right. And then it says, the first thing it says is to calculate what g of 7 is. All right. So what does g of 7 mean? So g of 7, g is f inverse. So that means the x of g is the y of f. So finding g of 7 amounts to solving 7 equals x cubed plus 7x plus 4. So this is what I mean, it's difficult to get the x. It's as difficult to get this x as it would be to solve the inverse function. Right? How am I going to solve that and get a value? So one thing you can do is subtract the 4, and you get 3 equals x cubed. Actually, I guess that is that's a 2x, isn't it? Where am I getting this problem? Number 9, x cubed plus 2x plus 4. That is a 2. Because otherwise this problem would be unsolvable. So plus 2x. All right, so 3 equals x cubed plus 2x. So now what you have to do is sort of look at this and say, all right, how am I going to solve this for x? You can't really, because if you try to get 0 and factor it, there's no way to factor it. So what you do instead is you say, well, let's just think about some values I could put in here, like 1, 0, and negative 1. Well, if I put in 1 cubed plus 2 times 1 is 3. So x equals 1. So I can sort of solve this equation by trial and error, really, right? And remember, guess and check. All right, so now I know that g of 7 equals 1, and that means that f of 1 equals 7. So now I can say what g prime is by saying that g prime of 7, according to my theory up here, is going to equal 1 over f prime of 1, right? So remember where y equals f of x, this is the y, this is the x. F of x equals y, this is x. See, but you have to be careful because this is only x and y in the context of f. So if you shift your perspective and look at g, the x's and the y's switch. This is dyslexic nightmares, one of the reasons I don't like this theorem. But anyway, my personal feeling about the theorem is not relevant. X cubed plus 2x plus 4 is what f of x is, so we need to know what f prime is. So f prime is 3x squared plus 2. Therefore, f prime of 1 is 3 times 1 squared plus 2. So it's, why do I have different numbers at different places? Where do I get 7 from? So I can't read my own handwriting is the deal. All right, so that's 5. All right, that's what f prime of 1 is. So this equals 1/5. There you go. Okay. Let's keep going. Let's look at number 10 in this section. So for number 10, right? Well, you know what? Let's save number 10 for the next video.